So we're going to be doing section 7.4, problem number 24. The problem is x squared minus x plus 6 over x cubed plus 3x dx, the integral of that. And so basically for this problem, we're going to be doing partial fractions. The first step would be to factor out an x in the denominator of this. So then that would equal the integral of x squared minus x plus 6 on the top over x squared plus 3 on the bottom dx. And so here you can see that this is going to equal the integral of a over x plus bx plus c over x squared plus 3. Then you are going to set the numerators equal to each other. So x squared minus x plus 6 will be equal to a plus bx plus c. And then you'll have to cross multiply. So a will be multiplied by x squared plus 3, and bx plus c will be multiplied by x. After factoring it out, you get x squared minus x plus 6 equals a plus b times x squared plus cx plus 3a. Then after that, you can see that a plus b will equal 1. Cx will be equal to -1, so c will equal -1. And then 3a will be equal to 6. And so with this, you can see that a equals 2. And then you can plug a into this one to see that b will be equal to -1. And then you have c equal to -1 as well. And then so after that, you can take, you can plug them back into this. And so that'll equal 2 over x plus -1 minus -x minus 1 over x squared plus 3. And I'm going to dx, and I'm going to switch those around just so the negatives don't get in my way. So -x minus 1 over x squared plus 3 plus 2 over x dx. And so now what you can do is separate these into two separate integrals. So that'll be the integral of -x minus 1 over x squared plus 3 dx plus the integral of 2 over x dx. Another step that you can do is also factoring out the 2 on that one, so we can do that. That'll equal -x minus 1 over x squared plus 3 dx plus 2, integral of 1 over x dx. After you have that, you can separate these into two different fractions. So we can take this and see that this is -x over x squared plus 3 minus 1 over x squared plus 3 dx plus 2 on the outside of 1 over x dx. And then now for this, you can see that for this fraction, you can take the u substitution. And so u would be x squared plus 3, du would be 2x dx, and then you can see that 1/2 du is equal to x dx, which is what we have. So we can factor that back in, and that would be -1/2 on the outside, 1 over u du, and then you can take this separate integral, dx plus 2 or 1 over x dx. And then now you'll have to factor out a 3 from the denominator in this one, because that's going to equal the inverse of tangent. And so you'll have to do 1 over 3, x squared over 3 plus 1. And so that is going to equal inverse tangent. So you're left with, now looking at this, you can see that this is another u substitution, and since I already used u, I'm going to use v. So for this one, I'm going to bring this along here. V will equal x over rad 3, and dv will equal 1 over rad 3 dv. And so what you have left would be minus 1 over rad 3, integral of 1 over v squared plus 1 dv plus 2, 1 over x dx. And so now that equals 1 over u du. This equals the inverse tangent, and so that's tan inverse of v over all over rad 3 plus 2, 1 over x dx. Gonna flip the page. Then you come back, and the integral of 1 over u is ln of u. And then the tan inverse stays there right now. And then the integral of 1 over x is just ln of x, and then the 2 was on the outside, so 2 ln of x plus c. Now we just plug in our terms, our u's and our v's, and so u was x squared plus 3. Tan inverse v was x over rad 3, and that's your x over a. And then 1 over a was your 1 over rad 3, and then plus 2 ln of x plus c. And that is your final answer.